Alright, let's take a look at the section 2.3 worksheet where we're talking about linear functions and slope. The slope-intercept form of the equation of the line is written as y equals mx plus b, where m equals the slope of the line and b is the y-coordinate of the y-intercept. So when I look at this first equation, y equal 2/5 x plus 3, the slope is always simply the number that is multiplied by x when y is on one side of the equation by itself and everything else on the other side is written in simplest form. So the number times x is 2/5. The y-intercept is the constant on the opposite side of the equation from y when that side of the equation is in simplest form. So in this case, that's 3. Now here in the second situation, we have the slope and we have the y-intercept. And actually, let's write our y-intercepts in the form that the ones that are already written are given. And that is to write it as a point with coordinates. So we'll write this as 0, 3 for number 1, going back to number 1. All right, so here our y-intercept is 0, 2. So that basically means our b is 2 and our m is 3. So the equation of this line is y equals the slope times x plus b. And remember, b is the y-coordinate of the y-intercept. Here I'm given the line equation, and I am asked for the slope. So let's give that. Remember, that's the constant multiplied by x if y is on one side of the equation and everything else on the other side of the equation is simplified. So m is -1/3, and b is the constant on the side of the equation that has x in it, as long as that side is simplified. And so the constant on that side is -3. So that's my b. Here I'm given my slope, and I'm given my y-intercept. And what's different about this is that my slope is 0. So I'm going to go off the chart for a minute to talk about that. First of all, we're going to just follow our pattern. Y equals our slope, which is 0, times x, plus our b, which is the y-coordinate of our y-intercept, and that's -5. But remember, 0 times any number, no matter what x is, 0 times that x or any other number is always 0. So this is 0 plus -5. But 0 plus -5 is just -5. So our equation is y equal -5. And notice, anytime I have a horizontal line, the form of the equation will always be y equal to some constant. All points on a horizontal line have the same y-coordinate. X changes, but y must be -5. X can be any real number value. All right, now we notice in this fifth equation, y is not isolated on one side of the equals. So what we're going to do here is we are going to solve this for y. So in order to get our information, we have to solve 5x minus 6y equal 24 for y. So we're going to do that by subtracting or adding. We can think of it as subtracting 5x or adding a negative 5x to both sides of the equation. So negative 6y equals negative 5x plus 24. Remember, to subtract 5x is the same as adding a negative 5x. And then I'm going to divide every term by negative 6 in order to isolate y on one side of the equation. And what results is y equals positive 5 over 6 times x minus 4. So I can see from that that my slope is 5, 6. And my y-intercept is the point 0, negative 4. B is negative 4. And I'm going to go back and put this in the form that all the other entries in this column are in, this third one. All right, so that would be the missing components of the table. And when I put a component in, I'm putting it in the form of the components that were already present in the table before I wrote anything in. So those are my slopes and my y-intercepts. And on the last two, I did have a little bit of work that I needed to do in order to actually fill in the information. And remember, number 4 was a horizontal line, and that is a line where all the y-coordinates are the same. The requirement to be on this line is that your y-coordinate is negative 5. Your x can be any value, but your y-coordinate must be and only can be negative 5. So a horizontal line always has that form. The equation merely gives the y value of every point on the line. All right, let's look at number 6 through 12, where I want to write an equation for each line illustrated in each graph. Now, when I look at this first equation, I can see that here's my b, and I can see that b is 2. I can see that I'm hitting the y-axis, if I'm on this line, at y equal to 2. So my y-intercept has a y-coordinate of 2. Then from this point on the line, I want to move vertically until I get to a point, until I'm directly across from a point that's crossing through one of the corners. So I could either move up, and I notice if I move up 1 unit, to my right, there is a point hitting one of the corners of my grid. So if I move 1 unit up, I then have to move 1, 2, 3 units right to remain on this line. And that's this point right here. So that tells me I made 2 positive movements from one point of this line to another. So I moved 1 unit up. I always give the vertical movement first. And I moved, 1, 2, 3 units right. I also could have moved 1 unit down, and then I would have had to move 1, 2, 3 units left. So if here I moved up and right, both of those movements are positive. I also could have moved 1 unit down and 3 units left. Both of those movements are negative. So when a slope is positive, either both of my slope movements are negative or both of my slope movements are positive. And remember, the slope is rise over run. Rise talks about how the y's are changing. Run talks about how the x's are changing. So I see that this line has equation y equals 1/3 x plus 2. Here I have a horizontal line. And notice that I have no rise on this line. My run from one point to another, notice my y-intercept is -3. And my slope, which is rise over run, my slope has no rise. I don't move up or down if I'm at one point of this line to get to another. So the rise is 0. And the run, it could be any value, any number. To get from one point to another, I move any number of units. Here, to get from this point to this point where y is -3 and x is 1 unit. I could put any number down here other than 0. So to get from one point to another, it depends on which point I'm at. But the key is this slope is 0. And remember, when our slope is 0, we have y equals 0x plus our b. So y really will just equal our b, which in this case is -3. So y equals 0 times x plus our -3, which equals 0 minus 3. Y equals -3. All right, number 8, we see that our b, our y-intercept, is -2. And remember, I can move up or down. I'm going to move down in this case, and I want to move down until I'm directly across from a point that is intersecting one of the corners of the grid. And I'm going to highlight that point in red. All right, so I'm starting at this y-intercept, and I'm moving down. Let's count our units. I moved 1, 2, 3 units down, so that's a -3. Down is the negative vertical movement. And then I moved 1, 2 units right. Right is a positive movement, so I've got a negative over a positive. Similarly, I could have moved 1, 2, 3 units up. And then I would have needed to move 1, 2 units left. So notice how whichever way I decide to go from that y-intercept, notice that one of the movements is positive and the other movement is negative. So I either move down and right, or I move up and left. And the point is, once I move vertically, I then move horizontally until I return to the line. And so the slope is negative 3/2. Remember, when you have a negative fraction, that negative sign can be in one of three positions. It can be level with the fraction bar, it can be with the numerator, or it can be with the denominator. So the slope times x plus my b gives me y equals minus 3/2 x minus 2. All right, here I see that my y-intercept, as I go to number 9, is 7. And I want to move until I'm, in this case, the grid is set up a little different, but I want to make a movement until I'm directly across from a point on the line whose y-coordinate is an integer. And I'm going to go to this point right here. That's not on a corner this time because the grid's set up a little different, but I am directly across from the integer y value of 1. So let's see what our movements were. First of all, our b is 7. And now let's find our m. So from this point, I'm moving 1, 2, 3, 4, 5, 6 movements down. So that's a negative 6, since I went 6 units down. Down is our negative vertical movement. And then I'm moving 1, 2 units right. So negative 6 divided by 2 is a negative 3. And in this case, I didn't go up because that took me off the graph. So this line equation is y equals negative 3x plus 7. Number 10. I see that my y-intercept is negative 3. So b is negative 3. And again, as most of the other ones, I want to move until I am directly across from a point whose y-coordinate is directly across, horizontally aligned with an integer. And in this case, the integers are on the corners. All right, so I'm going to move till I get to that highlighted red point there. And I need to move 1, 2 units up. Up is the positive vertical movement. And from this 2 unit upward movement, I need to move 1, 2, 3 units right to return to the line. And that is the positive, right is the positive horizontal movement. So the equation of this line is y equals 2/3 x minus 3. All right, here this line has a y-intercept of 0, and I see this point is horizontally aligned or directly across from an integer y value, and I notice that, again, my b is at the origin, so that means b is 0. M is 1 unit up, so from this point, I need to move 1 unit up to get to my second selected point. So that's a positive 1 since I moved up. And I had to move 1 unit right to get to that point on the line. Right is the positive horizontal movement. So my slope is merely 1. B is 0. So in this particular case, y is equal to 1 times x plus 0, which is simply x. So my equation is y equal to x. And it looks like I should have said 6 through 11 here instead of 6 through 12. Sorry about that error. Finally, let's just fill in these blanks. A line with a positive slope slants up from left to right. So in other words, a line with a positive slope is uphill, meaning as you move from left to right, you're slanting up. A line with a negative slope slants down from left to right. So in other words, if your slope is negative, you're moving downhill from left to right. So you would have a look along this line or in this fashion. A horizontal line has 0 slope. So remember, horizontal line, there's no change in y. And a vertical line has undefined slope. And the reason that happens is when a line is vertical, there is no run, and your rise could be any non-zero number. So you have a rise over no run, which means you're going to have some number divided by 0. And the key is the rise is non-zero. But the run is 0. And remember, this is undefined because division by 0 is undefined. So you can't divide by 0. And that's why the vertical line has an undefined slope. And remember that a vertical line will always have an equation where x equals some constant value. So your x must be a fixed value. In order to be on this vertical line, all points on that line have the exact same x coordinate. So your x is constant, your equation only gives information about x. All right, so this is the section 2.3 worksheet, and I guess you could call this a workshop. Anyway, I hope this was helpful, Happy studying.